Here's another volume integral, meaning we integrate the function 1. And let's understand what the domain of integration looks like. So first of all, we are inside the cylinder x squared plus y squared less than or equal to 1. But on the top up here, this is cut through by the plane x plus y plus z is equal to 4 that descends like this and cuts it in a sort of skewed way. And we would like to find the volume of this cylinder. And I'm sorry, the volume of this 3D region. It's not really a cylinder because the top is cut by this other plane. And let's write this as, let's call it U. And let's try to represent it in terms of cylindrical coordinates. So we have all the r thetas and c's. And now we said that this plane up here is x plus y plus z equals 4. So if we solve for z, we get 4 minus x minus y. However, everything needs to be in terms of r theta and z. So we will have that z is between 4 minus x. So instead of x, I'm writing r cosine theta and minus y. And instead of y, I'm writing r sine theta. And here r is simply between 0 and 1. And theta is between 0 and 2 pi. Okay, so this is our domain. And so the volume of this domain, of this 3D region, is going to be the following integral. So we're going to start with integration with respect to z from 0 all the way to 4 minus r cosine theta minus r sine theta. And so that is going to be 1 dz. And then the other integrals are much simpler. So we have 0, 1 dr and 0 to 2 pi d theta. The integral, as we said, is 1, and that doesn't change in any kind of coordinates. And we shouldn't forget to multiply by the Jacobian of the cylindrical coordinates, which is r. So now finding the antiderivative here with respect to z is pretty straightforward because r is a constant. So we will have rz from z equals 0 to z equals 4 minus r cosine theta minus r sine theta. And then we have dr d theta. And this is going to be the integral from 0 to 2 pi of integral from 0 to 1 of 4r minus r squared cosine theta minus r squared sine theta dr d theta. Now we are going to integrate with respect to r. So this is going to give us 2r squared minus r cubed over 3 cosine theta minus r cubed over 3 sine theta. And we would like to go from 0 to 1. And when we say 0 to 1, we mean r equals 0 and r equals 1. And once we do this, we're going to get 2 minus 1/3 cosine theta minus 1/3 sine theta d theta. This should be a very simple integral. And we can find the antiderivative right away. So this is going to be 2 theta minus 1/3 sine theta plus 1/3 cosine theta, going from 0 to 2 pi. Now, things here are especially simple. Think about it this way. First of all, sine of 0 and sine of 2 pi are both 0. As for cosine of 0 and cosine of 2 pi, they're both 1, so when you subtract them, you get 0. So the only contribution that you get for this difference is really from the term to theta. So it's 2 times 2 pi, which is 4 pi, minus 0, which is 4 pi. And 4 pi is the volume of this solid. And that concludes our problem. Thanks for watching.